So today we're going to start going over how to divide monomials, but we're going to do more complicated examples. We've already touched on this topic last quarter, but we're going to, again, do more examples where there is more involved in solving it. So we're going to go over 3 basic things you should be doing as you solve these problems. First thing is, you should be rewriting the problem. That's where you write out the fact that you subtract the powers. Second thing is you're going to reduce the fraction, because a number in the denominator will not always divide evenly into the numerator. That's going to be a change this quarter. And the last thing we'll get into a little later. So we're going to first take care of these first 3 examples. So first example, we're going to rewrite this. So I'm going to take my 8 and my 20, and I'm just going to write it as a separate fraction. I'm going to write my x and use the rule that you take the 2 powers and you subtract them. So I'm going to write that out as 10 minus 7. I'm going to spend the time writing this out because it will be necessary for later problems and it avoids mistakes. Now, 20 doesn't go into 8, so I'm going to have to reduce that. So I'm going to write that out. I'm going to reduce the numbers by dividing the top and the bottom by 4. 4 divides into 8 and 20. So I'm just going to write it here on the left because I don't have that much room on the right. When I divide by 4, I'm going to get 2 on the numerator and 5 on the denominator. And I'm going to be left with x to the power of 3 after I subtract the exponents. This is my answer for number 1. We're going to move on to number 2 now. Positivity if you need more time. So number 2, same idea. We're going to start by rewriting the fraction, 15 over 25. I'm going to rewrite each x power. So I have an 8 minus a negative 2. So that's a double negative. So I'm going to make sure I write that down. 8 minus a negative 2. I'll put it in parentheses. Again, we have a double negative, so that ends up being a positive because a negative times a negative is a positive. So I'll write that out in a second. But first of all, I'm going to go ahead and reduce my fraction. I could divide the top and the bottom by 5. That's going to give me 3 over 5. X, 8 minus a negative 2 is going to give me a positive 10. This is my final answer for number 2. Positivity if you need more time. I'm going to move on to number 3 now. Same idea for number 3. We're going to go ahead and rewrite the fraction, 12 over 16. I'm going to take my x. I'm going to subtract the powers, which are 10 and 8. So it's going to be 10 take away 8. I'm going to do the same thing for the y's. Y is going to be 12 minus, there's no number on the y. Remember, it's an invisible 1. And then I'm going to finish it off by doing my z. But notice the z's have the same power, so actually I can eliminate them. So the z's are gone, so I can just cross them out. If anything is the same on the top as in the bottom or in the numerator and the denominator, they eliminate. I'm going to now go ahead and reduce my fraction. I can divide both of these by the number 4. So I'll be reducing by 4. And that is going to give me a 3 on the numerator and a 4 on the denominator. 12 divided by 4 is 3. 16 divided by 4 is 4. My x value is going to be 10 minus 8. My power is going to be 2. For my y variable, I'm going to have 12 minus that invisible 1. It's going to give me y to the 11th power. This gives me my final answer. Let's move on to the next slide. Alright, so now that we've done problems 1, 2, and 3, let's talk about the third step, which we did not cover in any of these examples. That has to do with the negative exponent rule. So let's get into that. And whenever you have a negative exponent, you always want to make all negative exponents into positive exponents. So we do not want to have answers with negative exponents. So how do we do that? We're going to use this rule right here. Make sure you write it down. Whenever you have anything to a negative power, you always do the reciprocal, and you can switch the negative power into a positive power. What do I mean by the word reciprocal? That means you do the inverse of it, or you put it 1 over itself. So a general way of thinking of it is, if I have a negative power in the numerator, I can just move it to the denominator. Or backwards, if it's in the denominator, I can move it to the numerator to make it positive. So it's just a switch. So we're going to go over how to do that in the next 6 examples below. So here's number 1. We have x to the power of -5. We do not want negative powers, so I'm just going to do its reciprocal. So even though it's not a fraction, I can think of it as being a fraction over 1. So it's currently in the numerator. If I move x to the -5 down, I can put it underneath and switch it to a positive. Now there's nothing left on the top, so I'm going to put a 1 on the top. So that's pretty much it, how I change from a negative exponent to a positive exponent. Let's look at number 2. Number 2, it's a to the -7 on the denominator. If I want to make it into a positive, I can switch it to the numerator. So I'm going to put it at the top of the fraction, a to the +7. So I went from the denominator, I moved it to the top, it becomes positive. I can put a 1 at the bottom, or I can just simplify this and just put a to the 7th. You don't need this 1 in the denominator in your final answer. Number 3, I have 3 variables. Only one of them is negative, this one right here. So I want to make sure I make that one into a positive power. So I'm just going to take this one, and I'm going to switch it from the numerator, and I'm going to move it down to make it positive into the denominator. So I'm going to keep the p4 power on the top, and I'm going to keep the n to the 7th on the bottom. I am going to take my m variable, and I'm going to move it to the denominator. It doesn't matter which side you put it on the left or right of the n. As long as it ends up in the bottom, you're allowed to make it into a positive 1. You can leave it with the 1 or without the 1. It's the same thing. Without the 1 is a better answer. But that is pretty much how you switch it from a negative to a positive power. Let's go ahead and look at the next 3 examples. Here's number 4. Notice on number 4 we have 2 negatives in our exponent, so we're going to have to switch the x to the bottom and the a to the top. So I'm going to go ahead and start doing that now. So I'm going to leave the y to the 3rd and the b to the 5th where they're at. They're already positive powers. I am going to go ahead and switch these 2 from where they're currently at to the opposite side, and that's not working out for me. Let's use the highlighter. So I'm going to go ahead and put a to the -1 on the top as a positive 1. With or without the 1 is fine. X to the -4 is going to go to the bottom, but it's going to become a positive 4. And that's my final answer. That's how I changed from negative to positive exponents. Let's go ahead and try the next one. So in this next one, I have the S and the Q that need to switch locations from top to bottom and bottom to top. So I am going to leave my R10 at the top and the T7th at the bottom. Again, order doesn't matter which one's on the left, which one's on the right. So the Q is going to go to the top with its power of 3 now positive, and the S is going to go to the bottom. Its negative power is going to become a positive power. So I've just switched everything from a negative power to a positive power using the negative exponent rule. Let's get into this last one. Here I'm going to have to make 3 changes: the C, the W, and the X. They're going to switch spots. So I'm going to go ahead and move them. So I'm going to leave the 8, A, B4 at the top. The Y5 is going to stay at the bottom. And I'm going to switch the other 3 from top to bottom and bottom to top. So the C, -3, is going to go to the bottom. The W is going to go to the top, and so is the X. Let's make it a little nicer. And I'm done switching my negative exponents to positive exponents, and that should not be a 5, that should be a 2. There. Let's go ahead and move on. All right, so here we have just 4 examples where we're going to be putting it all together. We're going to be rewriting, simplifying, and reducing it all, making all powers positive. So let's start off with number 1. Here's a little bit bigger. Again, make sure you write big enough so you can see what you write, but leave enough room to solve all the problems. So I'm going to write a little bit bigger so you guys can see it on the video, but you may want to write big enough to fit it all in your paper. So I'm going to start by rewriting it. So it's going to start with a 10 over 22. I'm going to subtract my powers on the x's, the 8 and the 3. So it's going to be 8 minus 3. Do the same thing for the y's. 4 minus 7. And the z's. 5 minus, remember that's an invisible 1 at the end. Go ahead now and reduce all of this. So let's go ahead and reduce the fraction 10 over 22. The 10 and the 22 are both divisible by 2, so I'm going to divide both of them by 2. If I divide them by 2, I get 5 over 11. Now for this one, we are going to go ahead and write out our powers, x to the 5. At the end, we were going to change everything to positive powers. So for now, we're going to keep the negative there, just to simplify. Now, third step is to make everything positive. So the way we can think of this is everything is currently on the top. So let's go ahead and move just the y to the bottom. So let's write out our final answer. 5x to the 5th, z to the 4th, and in the denominator we have the y to the now positive 3. Here is my final answer. Let's go ahead and move on to number 2. So start off the same way. Oh, I went too far. Let's go back to number 2. So start off by writing it out. So let's start with 60 over 45 and subtract 6 minus 5 and is 2 minus a negative 7. Get in the habit of writing it out because that's where the mistakes happen. And then we have p to the 5th. There's nothing at the bottom for p, so it stays p to the 5th. There's nothing to do there. Let's go ahead and start reducing our fraction now. I can divide these by, so most commonly people will notice that they divide by 5, but there's actually a bigger number. So there's actually 15 divides into both of them. So I'm going to divide by 15. Now let's say, what if I don't divide by 15 and I divide by 5? You'll have to reduce it a second time. So let's just do it a faster way all at once. So 15 goes into 60 4 times. 15 goes into 45 3 times. My m is now going to be a 1. My n is 2 minus a negative 7. Double negative is positive, so it's going to be a 9 and p5. So here we have no negative power, so we don't have to worry about switching anything up, but let's write it as one big fraction. So I'm going to write it 4m, I'm not going to write the 1, and 9 p5 all over 3. This is how you will see your answers on a multiple choice test, as one big fraction. Let's move on to the next one. Here's number 3, same thing. Here it's a little different. We're just dividing by 4 here. So there's no powers to simplify, so just divide the first term by 4 and then divide the second term by 4. So this, if you want to do it in 2 steps, would look like this. 20x divided by 4 plus 12 divided by 4. Each one is individually getting divided by 4. So that's going to be 5x plus 3. This is a quicker answer. It's a binomial divided by a monomial. Let's go to the last one. It's going to be the same thing. This next one, they're both getting divided by 8. So here we have negative 32x divided by 8. And that same negative gets distributed to the other one. So we have a negative 40 divided by 8. Let's go ahead and simplify this. We have 8 into 32 goes 4 times. Let's not forget our negative. And the double negative here becomes a positive. 8 goes into 40 5 times. And that is my final answer. 4x negative plus 5. And I believe that's the end of the video. We're going to go ahead and do this right pair share after the entire class is done.